All right, so this one, 12.2, we're going to talk about arithmetic sequences. And we saw an arithmetic sequence in 12.1. That was I think, the first example that we did where it's kind of looks like a linear function. So an arithmetic sequence, like it says at the top, the simplest way to generate a sequence is to start with a number, add a fixed constant d over and over again. So the arithmetic sequence, we have our first term, the next term would be a plus d, the next term would be this term plus d again, so that'd be a plus 2d, and then a plus 3d, and so on. So notice that we have the first term, the second term, the third term, the fourth term, the fifth term. So the thing I want you to pay attention to, that's the second term. The coefficient with the d is 1 less than n. So our formula here is the nth term would be a plus n minus 1 times d. And so that is the formula that you need to either remember, or it's actually not too hard to figure it out if you forget. But let's look at this first example. So we have the common difference, which is d. Find the common difference, the first 6 terms, the nth term, and the 300th term. So to find the common difference, given that it is an arithmetic sequence, the way to see if it's an arithmetic sequence, if you're not given that, would be to subtract each term, subtract one term from the term that comes after it. So start with this with 7 minus 13, so -6. Look at the next one, 1 minus 7, we get -6. -5 minus 1, we get -6. So that's a way to tell that this is an arithmetic sequence. If these are different, then it's not an arithmetic sequence. Maybe a different kind of sequence may not really have a name. So the d is -6. Now we can get a formula. So a sub n, the first term is 13, and then that would be plus n minus 1 times -6. And we can simplify this. So 13 minus 6n plus 6. So that would give us 19 minus 6n. So now, if we want the first 6 terms, so we had the first 4 terms. So let's just start with a 5. So that would be 19 minus 6 times 5. And we could, of course, subtract 6 from that, which would give us -11. And then a 6, we could either do 19 minus 6 times 6, or we could do -11 minus 6, but either way we get -17. So this would be the nth term. There is our common difference. There is we have given the first 4, there's the 5th and the 6th, and then the 300th, we can just plug in 300 for the n. So it may have done this a little bit out of order from the way they want you to do it, but that's okay. So that would be 19 minus 6 times 300, which would be -1781. Okay, so of course, like with a lot of things, memorizing the formula is key for this. So here we have the 11th term of the sequence is 52, and the 19th term is 92. So let's find the 1000th term. Now, obviously, we don't want to just go from there, term by term. So what we can do, we can say A11 is A plus n minus 1, so that'd be 10 times d. A19 would be A plus 18d. So we know that A11 is 52. So we can set up a little system of equations here. So A19 is 92. So that's A plus 18d. And so we can solve this system of equations. If we subtract these two, we get -40. The a's will cancel. We have 10d minus 18d, so that'd be -8d. So d is 5. We know that d is going to be positive because we're going up. The sequence is going up. So d is positive, and then we can just plug that back into one of these. So 52 equals a plus 10 times 5, and so a is 2. So our general term here would be 2 plus n minus 1 times 5. And then we can find the thousandth term. So 2 plus 1,000 minus 1 times 5. And so that would give us 2 plus 999 times 5, which is 4,997.